My dear friends, in previous videos, we were able to use an ESP8266 module in an ESP01S package, program it with our Arduino development environment, and place it on a single-channel wireless relay board to turn it into a smart relay with Wi-Fi connectivity on a local network. By installing and configuring the ESP Relay app, we were able to wirelessly control the relay module, turning a 110-volt light bulb on and off. Some people have asked me, but what if, instead of having a single-channel module, I have a 2-channel module? Or a 4-channel module? Could I use the same procedure? In this video, we'll follow the same procedure we've learned from previous videos to program a single-channel board as a Wi-Fi relay, but this time on a 2-channel board, meaning with 2 relays. This time, I'll teach you how to add a second relay to your wireless control system. This knowledge will help you add as many relays as you need to your system. Whether you use a 2-channel module, a 4-channel module, or an 8-channel module. Adding the relays both in the ESP Relay app and in the code or program in our Arduino development environment. This will give you the following result. Welcome, and I hope you enjoy the video. At first, I thought about making this video with a relay board using a module based on the ESP01 packaging of the ESP8266 integrated circuit. However, when I searched for ESP8266 based wireless relay modules on Google, I saw in the search results that these types of boards with ESP8266 modules in ESP12 packaging were gaining momentum. Likewise, when I searched for these types of ESP12 modules on the Chinese website AliExpress and sorted them by best sellers, I saw that they were gaining momentum in the market over traditional modules. For this reason, it's reasonable to assume that these traditional relay modules based on ESP01 packaging are migrating to these modules based on ESP12 packaging of the ESP8266 Wi-Fi module. So, for the development of the practical part in this video, we will be using this 2-channel ESP12F relay module. This board, which I purchased for approximately $10 at local stores in my country, Colombia, has a detailed and well-organized design of its components, pleasing to the eye. This board features an ESP8266 programmable microcontroller module in an ESP12F package, a module that we will program throughout the video to achieve our goal of wirelessly controlling the board's 2 relays. It features 2 SRD05 relays. A power port for the board's electronics, where you have the option of powering it with 5 volts or 7 to 80 volts DC. 2 connection ports for the power circuits to be controlled, with a capacity of up to 250 volts AC, at 10 amps of current, or 30 volts DC, with 10 amps. The power load we wish to control wirelessly, such as light bulbs, appliances, motors, etc., will be connected to these ports. The board has a specific port for programming the ESP8266 module, a port through which we will load the program that will govern the operation of this board. It has a user port, with which we can connect, in addition to the 2 relays built into the board, external devices that can also be controlled by the ESP8266 module. A set of 2 pins to control the relays, labeled on the board as Relay 1 and Relay 2. As you can see, these 2 pins are open, meaning they are not connected to a specific pin on the ESP8266 module. Therefore, it will be up to us to choose which pins they will be connected to for their operation. It has an LED indicator for relay activation number 1, and an LED indicator for relay activation number 2. The board comes with a set of accessories, including terminal strips for pins, and a set of 3 jumpers, which we'll see how to place on the board in a moment. We must adapt the pin strips, placing them one by one on the board, the strip for the 2 relay control pins, the user port strip, and the programming port strip. We perform the respective tin soldering on the back of the board, leaving all the pin strips fixed. The first of the 3 jumpers is located by connecting the Relay 2 pin with the I04 pin of the user port. The second jumper is located by connecting the Relay 1 pin with the I05 pin of the user port. Regarding the third jumper, remember that to start any ESP8266 module in programming mode, where it will allow programs to be loaded from a computer, you must connect the I00 or GPIO0 pin with the ground or GND pin. This is why the manufacturer of this board strategically places these two pins together on the programming port. The third jumper connecting these two aforementioned pins will ensure that when the board is subsequently powered up, it boots into programming mode. We will use a USB to serial adapter module, in this case one with a CP2102 chip. However, you can use any commercially available converter module as long as the objective is to convert from USB to TTL serial. We will connect the TXD pin of the adapter to the RXD pin of the relay board. The RXD pin of the adapter to the TXD pin of the relay board. The GND pin of the adapter to the GND pin of the relay board. And the 5-volt pin of the adapter to the 5-volt pin of the relay board. Then we connect the adapter to a USB port on our computer. On our computer, we open the Arduino software. In a new sketch, go to Tools, then Board, and search for the ESP8266 boards. If no options appear for the ESP8266 board, you must install the resources for them. To do this, go to File, Preferences, and click on the URL Manager icon for additional boards. Here we click on the link to list the URLs of unofficial Arduino boards. An Internet window will appear with a list of boards from manufacturers other than Arduino, organized alphabetically. Here, we must scroll and search for the ESP8266 boards. When we find the ESP8266 community resource, we copy the link that appears there and paste it into the Arduino Resource Manager, separating it with a comma from the addresses that were previously pasted. Click OK, and then OK. Once the resources have downloaded, we open the Board Manager. And in the search bar, type ESP8266. In the search results, the resource for operating this type of board with Arduino should appear. Click Install. This will start the installation of the packages for all the different ESP8266 boards supported by Arduino. While the download is in progress, go to your Internet browser and paste the following link into the address bar. You'll find this link in the video description. It will take you to a GitHub repository where you'll find the Arduino code that will allow you to operate a single-channel relay module with the ESP Relay Android app. Copy this complete code and paste it into your Arduino editor. Let's test the functionality of this code. To do this, edit your network parameters, indicating the Wi-Fi identifier of your network, in this case the network where you want to connect your relay module. Indicating the password for that network. Indicating a password for the relay, basically an authentication for the phone app. I'll set it to number 1. And setting the ESP8266 pin that controls the first relay in your module. Which, according to as we connect our jumper on the board, the first relay is connected to the pin marked I05, we refer to this as pin 5 in our Arduino editor. Then we go to Tools, Board. We look for a board compatible with the ESP12F package. The most similar would be the Node MCU ESP12E, we select it. Then in Tools, we go to Port, and select the port where our USB to serial converter is connected. And click on Upload the code to the ESP8266 board. If you haven't done so already, remember that, prior to this upload, you must have placed the jumper between the I00 and GND pins of the relay board. This upload process will take about a minute. When you see this last message in the Arduino software output, we understand that the code has been uploaded to the ESP8266 board. Then we disconnect the adapter from our computer, remove the programming jumper from the relay board. This will leave the ESP8266 in normal operation, and reconnect the adapter to the USB port of our computer. In our Arduino code, we can see the communication speed we programmed for the ESP8266 module is 115,200 baud. Then we open the serial monitor in our software, and in the lower right corner we select this same communication speed. If after this action, we still don't see control messages on our serial monitor, we can press the reset button on the relay board, and we will begin to receive control messages from our ESP8266 board on our computer, specifically Wi-Fi connection status messages. In this case, they will indicate the IP address of the server mounted on our relay board, which was automatically assigned by our router. We must keep this numerical address in mind, since it will be our wireless connection point from our phone. On our Android phone, we can go to the Play Store, search for the ESP Relay application from the Creator DS programs, and install it on our phone. If you can't find it in the Play Store, I've left a link in the description to download it from the internet. Open the application. Using the plus symbol, add a new object to the panel. Enter a name for the relay. Enter the IP address, which we already know is our ESP8266 microcontroller. Finally, enter the password, which we previously assigned in our Arduino code. In this case, number 1. From this moment on, we can wirelessly control the first relay on the board. So let's learn how to add the second relay function to the board. Let's disconnect the serial adapter from the USB port, replace the programming jumper, and reconnect the adapter to the computer's USB port. In our Arduino code, let's scroll down to the handle root method. Just for reference, I'll mark with asterisks the beginning of the code section that controls the first relay, and the end of said code section. From this section of code, I'll delete the else structure, which authenticates with a password. I'll select this section of code and cut it from this location. Below and after the handle root method, I'll create two methods, one that checks the first relay, and another that checks the second relay. I'll name them according to my preference, check relay 1 and 2. I'll paste the section of code I cut from above inside the check relay 1 method, and also inside the check relay 2 method. Inside the latter method, I'll rename the variables of this second relay to differentiate them from the first relay. Password of the second relay, state of the second relay, pin of the second relay, and so on for all the variables inside this method. Then, inside the handle root method, where we marked with asterisks, we will call the check relay 1 method and the check relay 2 method, one for each relay. Then we move to the initial part of the code, where we parameterize the relays. And in addition to parameterizing relay number 1, we parameterize relay number 2, indicating the password for this second relay, which I will assign the number 2, and the pin of the ESP8266 module that controls this second relay, which, according to our jumper connection on the board, corresponds to pin I04, calling it pin 4 in the Arduino editor. Below, I will declare the second state variable corresponding to the second relay. And inside the void setup method, just like for the first relay, I will place the two startup instructions for the second relay pin, as a digital output, and with a low or deactivated state when the board is electrically started. We can verify or compile the code, to rule out any syntax errors during editing. And finally, we upload it to the ESP8266 board, thus completing its final programming. I'll leave this code for this 2-relay module in the description of this video. In the ESP Relay application, we add a second relay, I'll call it relay 2, with the same IP address as relay 1, and with the password assigned for this relay, which would be number 2, according to what we programmed in Arduino. After uploading the code to the board, we can disconnect and remove the USB to serial adapter. We can power the control part of our board. And that's it. We have wireless control over the board with both relays. Dear friends, I hope this tutorial was very useful. Best regards, see you in the next video.